Okay. Theoretically at Sec 2, right, or grade 8, all your quadratic equations were kind of solvable, right? Solvable by factorization method. Okay, so you could have a clean, easy factorization like this, like x plus 3 is equal to 0, then you will have x equals to 0 or -3, right? Basically, mode 3 on your calculators, actually. Okay. Occasionally, you can get something like this. Then you have x squared is equal to 8, x is equal to plus minus square root 8. Okay. What I really want to emphasize is this, with regards to squares, right? Okay, so if x squared is equal to 4, x is equal to plus minus 2, okay? But what about square root 4 by default? Is this equal to 2 or plus minus 2?
Equal to 2.
It's equal to 2. Square root by default is a positive operation, okay? You don't have to add the minus artificially. You add the negative artificially is when we are solving equations like this. This is a degree 2 polynomial, right? So theoretically, there ought to be 2 roots. Hence, we add in this plus minus by ourselves, actually. Hence, if you use the graphical calculator to plot the square root graph, it only shows you the positive arm, isn't it? Like this. If it's plus minus, there ought to be this guy, right? So the green arm is actually the negative square root x graph, actually. So if you were to plot something like this, y squared is equal to x, then it will be the red and green graph combined. Okay. So then you have something more intensive in terms of like questions 5 onwards. So I just want to check, how do you usually present your work for factorization? Would it be something like this, or is it this method?
For factorization, I would normally do the method where you do the
For the first one.
x and then -2, 4. No, -4, 2 in this case. Yeah.
So it's like -4 and plus 2, right? So the one on the left.
Yeah.
Okay. So we stick to this, okay? Because this is the preferred method as you progress up to senior years, actually. Okay. So this is the factorization method, and of course, the key thing is when the troublesome bit is when your leading coefficient is negative, it can get troublesome that way. So sometimes some students will write this, right? So this becomes 3x squared minus 7x plus 2 is equal to 0. When you choose to move from the question to the one in red, right, you are actually multiplying negative one on both sides. Hence, the polarity switches.
Oh.
Okay, but since it's 0 on the right side, it doesn't really matter that way. Okay. Otherwise, you can do something like this: minus 3x squared plus 7x minus 7x plus 2 is equal to 0. Okay, then you focus on factorizing the green bracket. Okay, this one just means that the original equation is not compromised or amended in any way at all. Okay, you're just rewriting it in a way where it makes it easier for you to factorize because of a positive leading coefficient of 3. Okay, understand? Okay, but otherwise, but the step in red isn't wrong, of course. The step in red just says that the solution to the red equation is the same solution to the original equation. That's all. Okay, multiplying by minus does not change the solution space or the solutions. All right, okay? So the start of grade 9 is to understand that not every quadratic is factorizable. And hence we kicked off with the quadratic formula, right? So this is one of those formula that when you first see it, it's like, oh, you need to keep on referring to the formula, but eventually you don't have to. Agree? So it's this, all right?
Actually, I think I kind of know all of this.
Yeah, that's why I'm skimming through this very quickly, actually. Okay, so you will realize that doing this page, right, doing this formula will relate to surds immediately, isn't it? Because you will need to simplify the surds. So for example, this guy, you will have -1 plus minus 1 minus 4, 1 minus 1 over 2, 1, which is equal to -1 plus minus square root 5 over 2. Okay. Occasionally, this guy can be broken down further, and that's where the surds come in then. So you have to watch out for these things. Okay. So blah, blah, blah. Then not every quadratic equation can be factorizable, but every quadratic equation can be pushed through the quadratic formula. And from there, we can assert whether would there be 2 roots, 1 root, or no roots, actually. Okay. So the key point in doing a math, right, is when you see a formula or doing math in general, when we give you a formula or an idea, right, you must be able to pinpoint what is the key element of that idea or the formula actually. When does it work? When does it doesn't work? What's the base case, the trivial case, and what's the extreme case actually? That means you can brainstorm and break it down into cases. Okay, so you don't take physics, right? This 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 element of what I just mentioned, right, doesn't really check out in bio and chemistry in general. Okay, but it tends to check out in economics and physics. So in physics, the notion is if I can understand this at a very microscopic level, and I can also understand this at a very astronomical level, right? Then everything in between should be trivial for me, right? Okay. In econs, it's the same thing. If you can understand the dynamics of the economics or the business cycle when you have no money versus when you are a millionaire, right? Everything in between should be trivial then. Okay, so it's like breaking into cases or study the base case and the extreme case. Okay, so if you look at the quadratic formula, right, you must the key observation must be okay. You will need b squared. The key attacking point must be the b squared minus 4ac, isn't it? Because when b squared minus 4ac is greater than 0, equals to 0 or less than 0, you have three different cases. Correct? So clearly, when b squared minus 4ac is less than 0, it causes the formula to break down, right?
Yeah.
Okay. And when b squared minus 4ac is equal to 0, you no longer have two unique outputs. Agree? Because it's minus b plus minus 0.
Yeah.
And when b squared minus 4ac is positive, is two distinct solutions then. Okay. So this property here, right, is unique to quadratic equation. The analogous property for cubic and above, right, is the difficulty level just scales up drastically actually. Okay, you can actually Google it. That is there a closed form formula for cubic polynomials? There is, but it's extremely difficult to derive. So degree 3 and degree 4, the jump in difficulty is quite huge actually. It's not even inside the IB syllabus. Okay, so this thing is what we call the discriminant. So it is the key element that will determine the outcome of the quadratic equation. Okay on this? So clearly for graduating Sec 2, I have all these exercises to let them go through the motion and make their own observations, which I won't put you through it, of course. Okay. And then you have this. So you must remember these four outcomes very, very well.
Oh yeah, I remember this.
Okay,
It's
so
been a while, but I know how to do it, I think. Like as long as it's if they say there's real roots, then it's this. Because then there can be
or two.
two.
Okay, can. And then sometimes we will use the word tangential. Tangential means one intersection, right, between a line and a curve. And then there'll be one real root. That means discriminant is equal to 0. Okay, because eventually you'll be learning a concept called differentiation. Then you may mix up tangential to the chapter of differentiation when the time comes. Okay, can. So if you look at exercises on this question, right, you will realize that the focus has shifted. In Sec 2, right, we are only interested in asking you to go and solve for x, right? Go and factorize, go and do whatever you need to do to solve for x at the end of the day. But in A math, right, there is a slight shift in paradigm. We are no longer interested in solving for x anymore. If you look at the set of questions here, right, we are actually interested in you solving for some unknown constants. I want to like create the conditions that give rise to the outcome that we want. Do you get what I'm saying? If you look at all these questions, these 5 questions here, right, none of them ask you to solve for x at all. Agree? It's always asking you to configure some coefficients, right, that will lead to the outcome that I want. Understand? So you must recognize this. So I'll just go through question number 4 with you. So let's say we have 3x plus k is equals to 5 minus 3x minus 2x squared. So the point is does not meet. Does not mean means no solution, means discriminant must be negative, right? Okay, so I will always shift such that my leading coefficient is positive. So I will have 2x squared plus 6x plus k minus 5 is equal to 0. So in orders of x, of course. right? Then discriminant is less than 0. B square minus 4AC is less than 0. Then 6 square minus 4, 2k minus 5 is less than 0. Then solve from there. Okay, so these things you should be very familiar with already, right?
Yeah.
So this is it. So this is the introduction to discriminant as well. So I just want to highlight that given a formula, right, you must be able to catch up what is the extreme situation, that's all, or the conditions that give rise, that makes the thing break down. Okay, theoretically, you have kind of been trained in this in E-math plotting of graphs, because we will always ask you what is the maximum domain of the function, right? Then you will always be thinking to solve where the denominator is equal to 0, because those are the values that must be precluded from the domain of the function for the function to be executable. So these are it's the same principle actually. Whenever we see an expression, we are interested in when does it break down or when does it operate. All right, Ken? So discriminant should be straightforward, right? So what is laborious, or the most laborious part of quadratic to me is actually the completed the squares form actually. Okay, trying to teach this. So you have for quadratics, you should have 3 forms in general: the polynomial form, the factorized form, assuming it can be factorized. So you can see that from the polynomial form to the factorized form that I have, I can only have the a on the outside because it's the leading coefficient. The b and c, how would they look like in terms of d and e, I will not know. Well, I cannot predict for sure. Okay, so here you have one more form, right? The completed the squares form. You need to be fluid in all 3 and be able to move between all 3. So, and you need to know the pros and cons of each of the 3 when it comes to sketching of graphs, actually. Okay. Okay. So how do your teacher go through completed the squares form usually?
So for example, if we do x squared minus 2x minus 3, so what we would do first is x squared minus 2x, and then we would make an equation. So x squared minus 2x plus 4.
Plus 4. Okay.
Yeah.
Okay.
And then I think x squared minus 2x plus 4, and then minus 4 minus 3, and then
Would he shift the minus 3 to the right hand side?
yeah, so it would become x minus um 2. So can I write this down? Sorry.
So so he will shift. So he will do this, right? Minus 2x is equals to 3, then plus 4 on both sides.
Oh, no. What we did was we would do x squared minus 2x minus, so we would put it in brackets. So x squared minus 2x plus 4 minus 4, and then bracket close minus 3 is equal to 0.
Yeah, actually, it's not plus 4, actually, it's plus 1.
Huh?
It's plus 1.
Oh yeah, it's plus 1, sorry. Plus 1 minus 1. So then it would become x minus 1 squared, and then we would take out the minus 1, and then minus 4 is equal to 0. So x minus 1 squared minus 4 is equal to 0.
Okay, so he actually won't bother to shift the minus 3 to the right hand side, is it?
No, he didn't.
So you're okay with this presentation, right?
Yeah.
And you also recognize that why do you need to create a 1, right? Is to create the situation of this guy, right? Because you're reverse engineering the a square minus 2ab plus b square here. Okay, so that's a good point. That's a good thing. Because some teachers, right, will actually say this, will actually teach this, like which is what I just said. So x squared minus 2x is equals to 3. Then on the left-hand side, you want to create a scenario now. So it's x squared minus 2x plus 1 is equal to 3 plus 1. Then you have x minus 1 squared is equal to 4. Then you shift it backwards. Okay?
Oh, what? That's so long though.
No, it's the same thing, right? It's just that I think the notion of doing this, right, is to so that you don't have to do the plus 1 minus 1 on the same side.
Oh.
So they just feel that adding 1 on both sides or subtracting 1 on both sides is a lot easier than add 1 and subtract 1. But the net effect are the same, of course. Okay. So same gameplay. So I will not go through this, but you must understand that completing the squares, right, is actually the reason why we obtain the quadratic equation, the quadratic formula actually. Have you been through the exercise before?
Wait, what exercise? This exercise?
As in like this formula. was actually obtained from the completing the squares mechanism.
Oh.
Okay, oh, so you haven't. Okay, we'll do this together then. If you can do this, surely you can do all other completing the squares questions already. Okay, so if you look at, so completing the squares, right, it's easy when your leading coefficient is 1, agree? But it's obviously difficult when your leading coefficients are 2, 15, and negative 1 and 2, right? And the point is you must factorize out the leading coefficient first. Remember? Is that how your teacher taught this?
Yeah.
Okay, so we do not go through something like this, all right? This is actually wrong. These two sides are not equal. 2y is not equals to y. Agree? So this is all right, because we are just dealing with an expression, not an equation. Okay. Okay. So moving to this one, right? So how to derive the quadratic formula 174? Let's just say if you have ax squared plus bx plus c. Okay. I want you to complete the squares on this right now. How will you do it?
Can I see the equation on top? Yeah, that the 2x squared plus 4x plus 5, right?
I want to do this guy,
Oh.
the abstract way.
To factorize this,
Okay. And what will you get?
wouldn't you just get negative b plus minus squared b squared minus 4ac?
No, you will just get this, right?
Oh. Yeah.
Okay. And then then what's the action to do completing the squares?
Um. Please. Ax squared plus b over ax plus b squared over 4a squared
Good. Okay. So
minus b squared over 4a squared plus c over a. So a x squared plus b over ax plus b over 4a squared, and then minus b squared plus minus b squared over 4a plus c over a. And so a x plus b over 2a squared minus b squared over 4a plus 4c over 4a.
square over 4a square. Okay.
So minus b squared plus 4c over 4a.
No, wait. There's a mistake with what you are saying. Check your work so far first. There should be 4a square, right?
But then didn't the 4a squared get cancelled when it came out of the bracket?
4a square will only cancel with 1a, right? You will still have 4 over a, right?
Yeah, it's still minus b squared over 4a,
Oh, okay.
right? So I yeah, that's what I did.
Okay.
And then I just combined the numbers. Um I did plus. Wait, why is C over A still in the brackets?
No, I opened up the brackets already.
Oh.
Yes, no?
Oh. Okay, I made a mistake. So it becomes yeah, it becomes that.
Okay. So then after that, you will shift this the non-bracket terms to the right. Over 4a, right, minus 4ac. So I'm combining the denominators. Okay, so you can see the b squared minus 4ac has emerged in the derivation. So the next step must be to divide by a, right? So you will have x plus b over 2a square is equal to b squared minus 4ac over 4a squared. Get it? Okay. Then what should the next step be?
Uh,
For x. Yeah.
you can square root x over x plus b over 2a.
Okay. So if you take square root on both sides, plus there will be a plus minus right now, of course. So it's plus minus square root of b squared minus 4ac over 4a squared, right? And 4a square root will give you 2a. So this is b squared minus 4ac over 2a then. Get it? And then, so the x is therefore minus b over 2a plus minus square root of b squared minus 4ac over 2a. And that's the answer then. And that's the quadratic formula actually. So this is how it's derived actually. Get it? Can? So these are like the actions of going through to get to the completed the squares form, of course. Okay? Can? Okay. So what is the strength of the completed the squares form? What is so useful about it actually? If you look at
Find the vertex.
find the vertex, how is it analyzed? So let me open up the third document. It's moving a lot faster than I envisioned, but good. Okay. So what's so good about the vertex then? So let's say this guy, right? If I turn this into the completed the squares form, I will have x minus 1 square minus 4, right? Okay, how is this done? Explain to me. How do we know that the vertex is 1, negative 4 then? What's the string of arguments?
Uh, I'm not sure, but I know it's 1 comma negative 4. That's it.
Yeah. So this must be the biggest learning point for you today. Yeah. So are we agreeable on this first? If you have a quadratic equation and we have this,
Yes.
okay, but why? Remember we went through this discussion before also.
Oh my god, yes. I don't know.
Okay. So
I,
you reference this example, right? Based on this, you have a quadratic term, you have a linear term, and you have a constant term, right? So the shape of the graph is either this guy or this guy, right? Okay, let me just remove the x-axis. Yeah. Okay.
yeah.
Okay. So has x, think about this, has x goes to like 1,000 or 1 million or negative 1 million, right? Of
Mm-hmm.
these three terms, which will be the most dominant term actually?
1 million?
No, the first, second, or the third term? Do you get what I'm saying?
No.
Okay, 1 million squared versus 2 million versus 3, which is the most dominant term?
2 million.
2 million is greater than 1 million squared. Are you sure?
Oh, wait, 1 million squared.
Do you get what I'm trying to say now?
Yeah.
So if 1 million squared is the most dominant term, right? And likewise, when x is negative 1 million, which is the most dominant term? Is it the squared term, the constant term, or the linear term then?
The square term.
Squared term. So in this case, whether x is positive 1 million or negative 1 million, by virtue of the fact that the leading coefficient here is positive, right? We will have a positive y value, right? As x goes to infinity or negative infinity. You get what I'm trying to say here?
Yes.
So of these two graphs, the first and the second graph, which fits the narrative that I just described actually.
Um,
Do you get what I'm trying to say?
the second graph?
But the second graph has got okay. I think you're not seeing the picture. If you have y is equal to ax squared plus bx plus c, right? Okay.
Uh,
So the idea is has x goes to infinity, and if a is greater than zero, okay. If x goes to infinity or negative infinity, of these terms, who dominates the most?
ax squared.
Ax squared dominates the most, right? Okay. But since a is positive, so net y should be positive, right? Has x goes to infinity or negative infinity. All right. Okay on this?
Yes.
Okay. So if you look at this graph that I have, this pair of graph that I have on the right, on the left side, if you look at it, as x goes to infinity or negative infinity, which of these two graphs depicts the picture then?
The first graph because it's both x and y is positive.
Which means the first graph has x goes to infinity, like infinity here or here, y is positive, right? Here and here, isn't it? Get it?
Oh yeah.
And you can, so obviously the converse story must work on the number two then. Get it now?
Oh, I get it.
That is the reason for this logic over here then, okay?
Okay.
The same logic can be applied to the cubic polynomials actually. Get it?
Yeah.
So so that will be the shape of the graph first. So okay, let's view on this same example. So x squared minus 2x minus 3. So x squared minus 2x minus 3, which is be known to be x minus 1 square minus 4, right?
Yeah.
Okay, so the first observation is it must be a U-shaped graph. Okay.
Okay.
Okay. So if
Wait, I have just one question. Next Wednesday, are you going to the censor?
no, we also actually tuition can only resume from the 21st regardless. So
Oh yeah, so it's not next Wednesday, next Wednesday.
I will have to see actually. I'm a bit skeptical about going back to the center anyway.
Oh, why? There
I
are.
mean, I mean it's just one more week, right? It will be the last physical lesson before your holidays end, right?
Yeah.
Yeah, so that's why I'm still thinking might as well just keep it online still regardless actually.
Oh.
Yeah. Because at least if it's Trigo, right, it will be the last lesson for in the short term for Trigo. At least if I can record it, is actually better for you all in the future actually.
Oh.
It's not like you all have a test coming out or something, right?
No.
Yeah, because for
I-
some of the seniors, they actually have got a test the moment school resumes for the IB years. So
Oh.
those guys I may go back to face to face as well. But it's not in a rush for you guys. So I'm not so it's a back burner for me to be honest.
Okay.
Yeah, right. So KIV on that. I mean, I just pass the message to your mom too also that
Okay.
just in case. I mean, they're already closing Ion for today, right? For the next 4 days, right? Did you read the news?
Yeah, ion. Like ion. How do you close ion? If you close ion, you can't get to Wheelock or Shaw or
Yeah.
or anywhere. Actually, ion is the linking point to every single mall.
Yeah. Who
If they
knows?
close ion down, then the Orchard Station is nothing.
Yeah. Right. Okay. So back to this. You have a U-shaped curve already. So
Mhm.
the vertex, right? What is the defining characteristic of a vertex in a U-shaped graph? Is a turning point, yes, but it's also a minimum point. Agree?
Mhm.
So if we go back to the completed the squares form right now, right? It's made up of a squared expression minus 4, right? So
Mhm.
what is the defining characteristic of a squared expression? It is always
It is always degree two
no numerical wise, its value is always
squared.
Oh no, as in it is never.
It is never it is never negative.
It's never negative.
Always positive.
Which means that it's okay. Strictly speaking, it's not just always positive. It's actually greater than or equals to zero. That's all.
Oh,
It can be
yeah,
zero.
because
So
it
it's
can be zero.
non-negative then. Okay.
Yeah,
Okay. Then if you take something that is always greater than or equals to zero, minus 4, right? So overall, this entire guy must be greater than or equals to
zero. Wait,
no. We have
minus 5. It has to be greater than minus 5.
why minus 5 though? If you take something that is perpetually 0 and above, right, and you lower it by 4 units,
Oh wait, then it has to be greater than negative 4.
so this will be greater than or equals to minus 4 then. Get it now?
Yeah.
Which means that the y value is always minus 4 and above, right?
Uh-huh.
Which means that the vertex, which we have really declared to be the minimum value point, the y
I
value must be minus 4.
understand. Oh,
And
because it has to be greater than negative 4, and then it just goes to negative 4, and then we use that to. Okay.
okay. And
Yeah.
when is it actually negative 4? When x is equals to 1.
1.
Because when
Ah.
this guy happens, get it?
Okay, I
That's
understand.
how the vertex is actually analyzed. And we do not have a luxury for this for cubic polynomials because cubic polynomials has got 2 turning points.
Oh, I did have something to ask about quadratics. I just completely forgot about it. So, you know how when they ask you if I actually asked you this question before, but like just to confirm because I've had a few other questions on it. So if they say like x squared minus 2x plus 4 is greater than 0,
For all x, right?
yeah, then what is k?
Yeah, I'll come to that later when we talk about the graphs.
Oh yeah, I cannot do those questions. Wait, is it just the opposite? Because I keep
No,
thinking it's the opposite.
it's a separate kind of questioning.
Oh, okay.
Okay, so do you understand what's going on now? How to use
Mhm.
a vertex form to actually analyze the turning point of a graph? Okay.
I do.
So likewise, if I have a reverse side, okay. So let me if I give you something like this, minus x plus 2 square minus plus 8 then, okay? Okay, so you lead me through the string of arguments that will declare the vertex or the maximum point in this case.
So basically, it's this is so anything squared cannot be negative.
Okay, so is this a U-shaped graph or N-shaped graph first?
It's a n-shaped graph.
Okay,
Wait, yeah.
which means that its vertex must be
A
is it a maximum point or minimum point?
maximum point.
Maximum point, okay. Okay, following which?
Um, following which so the squared value cannot be negative.
Okay, this
So
guy here is always like this, right? But you have a minus in front, so this guy is less than or equals to 0 then.
okay, so it's lesser than or equal to 0.
Mhm.
Um, and then you add 8 to it. So y has
Uh-huh.
to be always lesser than or equal to 8.
Okay. Get it.
So the maximum point is then 8 is then the y coordinate of the vertex because it has to like stop there.
Yep. And the corresponding x value is,
Corresponding x value is -2.
so we actually get the y value first, then we ask ourselves, what is the x value that led to it? Get it?
Mm-hmm.
So that's the whole point. So it's minus 2, 8. Get it?
Yeah.
So this is the strength of the completed the squares form. Neither the polynomial or the quadratic form, neither the polynomial or the factorized form could have given us this luxury of analyzing the vertex. Get it?
Yeah.
So consolidating all the strength of the three forms, we have this actually. Right, this one. Okay.
Okay.
And you must also couple it with the x and y intercepts to solve for whatever you need to solve for, of course.
Yeah.
So even for the factorized form, there are some hidden benefits. So if you have two distinct x-intercepts, the turning point is the midpoint, okay?
Yeah.
Which is the line of symmetry. When you have a polynomial form, you can use this formula right away, actually. This will only be taught, this formula will only make sense to you in Sec 4 when you learn differentiation.
Oh, my teacher actually taught this to us, though, I think.
You can just memorize this also for yourself. Okay.
All right.
Okay. Every quadratic graph will always have a y-intercept, which we can solve for by letting x be 0. And no, but not every quadratic graph will have a x-intercept, right? And it could be 1, 0, or none, or 2, sorry. And we will use that by factorization or quadratic formula whatsoever, that's all. Then, so we always need a turning point and xy intercepts and a shape, and then we can sketch the graph easily.
All right.
Okay, so as of now, I'm still not addressing the questions that you actually mentioned just now, that you were trying to describe just now, but we keep it to this one first. Understand?
Yeah.
So you must be versatile in all three forms. Obtaining them is one thing first, of course. Being able to infer the relevant information is another. All right. Okay.
Yeah.
Okay. So once this is over, then you can start start solving quadratic inequalities. So theoretically for yourself, you have the GC, so it's a lot easier. But AMF cannot use GC, right?
Yeah, we were not allowed to use the GC.
Okay. So let's look at these questions first. If you look at this set of questions that I have here, right, none of them are like what you just described, right? Where you need to solve for an unknown constant k. Agree?
Yeah.
They are all solving for x still. It's just like what I mentioned. This is like the set 2 kind of solving equations where you're solving for x explicitly. This is in contrast to the discriminant question, right, where you're solving for some unknown constants k that will control the outcome that you want in terms of having 2 roots, 1 root, or no roots. Okay? So what exactly is the difference, right? Number 1a, right, is just something that you can sketch the graph. If you can sketch the graph out, good for you, of course, because this is a U-shaped curve and the intercepts are half and -1, right? So let's say 1a, I can immediately sketch the x-axis. It's a U-shaped graph, -1 and half. Agree?
Yeah.
And the y-intercept must be somewhere here then. Okay, but when it comes to solving for a quadratic inequality, right, the turning point and the y-intercept don't matter to us at all. So most of the time, we do not sketch the y-axis. You can have it, but it's not needed at all. Okay.
Yeah.
And if you look at the questions wording, they want the range of the range of the graph when it is positive, right? When it is positive means it's hovering above the x-axis, correct? Agree?
Mhm.
You benchmark it against the Cartesian axis. Positive means it's here. So positive means it's here and here, isn't it?
So it's less than 1 and greater than half.
Less than -1, okay?
Oh, yeah, -1.
So it's with an open circle because it's an exclusive inequality, okay? And here then, get it? So the yellow highlighted regions are the parts of the graph that are the solution. But the question is asking you to solve for the corresponding x values. So when you drop set this bunch of guys down, right? So it's this guy and this guy then. Get it now?
Ah.
Okay, can? So I can actually sketch out the y-axis, and I can even tell you that the y-intercept here, based on this expression, the y-intercept is -1, and the turning point is some other values here, but it's not needed to solve the question at all, right? Is it? Agree?
Yeah.
So that's the whole idea behind this. So usually we just stick to this simple graph. Get it?
Mm-hmm.
So similar gameplay for questions like, let's say 1C. So we will solve for the roots explicitly first, if we can. So you have x, 3x plus 5, greater than or equals to 0. Then you will have 2 roots. This is a U-shaped graph once again. And the roots are 0 and -5/3. So they want the range that is positive. So it's here and here. Get it now?
Mm-hmm.
So then the answer is just x is greater than or equals to 0 or x is less than or equals to -5/3. Okay?
Yeah.
If it's factorizable, it's obviously a good thing. If it's not factorizable, you have to use the quadratic formula to obtain the 2 roots in third form then. Okay, you're not supposed to round off to decimal places or whatsoever, all right?
Okay.
Okay, so things like this, you know that you must always turn one side into 0. Why? Because when y is equal to 0, right? When one side is 0, right, it's as if you are solving for y is equal to 0 here, right? This guy is like y is equal to this guy. Get it? Y is equal to 0 is just the x-axis. It's so much easier to benchmark then. Get it?
Mhm.
So if you look at my 2C, right, 2D, right, I'm solving for the range of values for which the quadratic curve is less than the straight line that I have 4x plus 12. So mathematically, if I really want to sketch the graph, if you can actually use a GC to sketch the graph, it's like, oh, I have a quadratic graph, which is 2x squared minus 5x plus 7. Then I also have a straight line, 4x plus 12. So it could be somewhere like this.
Mhm.
So theoretically, if I actually just plot the graphs out like this, right, I'm solving for the range of values for which the blue graph is below the orange line. Agree?
Yeah.
So which will be this range of values, and then the answer, I must go and solve for the intersections, which is this B and A. So the solution is actually A X B. Agree? Between A and B, the blue graph is always below the orange line.
All right.
Okay, but of course you will not solve such a method. You will only use such a method to solve when the graphical calculator becomes available to you, even for all kinds of papers in future. Okay, at the
Okay.
secondary level, the way to do this is obviously to equate them first. So you want this guy to be less than 4x plus 12. Then you will shift everything to one side. So you'll be 2x squared minus 9x minus 5 less than 0. Then you will try to factorize this. Let's see if this is factorizable. So 2 minus 5, 1, 1. So it's 2x minus 1, x minus 5 less than 0. Understand so far?
Yeah.
So what is all these actions, what does all these actions convey, right? Is you are solving for an equation. We are functionally saying that to solve for this equation, which is the original intent of the question, right, is the same as solving this inequality then. Get it? It's just like when you solve equations, you shift a bunch of terms left and right, or you do some multiplication here and there, right? Those
Uh-huh.
are those are permitted operations because they all share the same answer. That means no matter what actions you do, the answers don't change. Get it? So right now, right, what was a very complicated looking expression at first, by our algebraic manipulation and factorization, we have turned it into a situation that is like this, which we can solve and infer the solutions very, very quickly. The answer would just be,
This is what I had to ask about. Like, what do you write as the answer if it's 2x minus 1x minus 5 is less than 0?
so that means this inequality on the latest inequality I have, they want a negative side, right? They want your graph to be less than 0
Uh-huh.
below the x-axis, isn't it? Agree? Below the
Oh,
x-axis.
so you just draw the graph.
Yeah.
Oh, what?
And then the
Oh,
answer is just half.
oh, wait, it was that simple. It was that simple. You could just draw the graph.
Yeah, you're supposed to draw the graph. You must always maintain the habit of drawing the graph. Don't try to memorize everything. Okay.
Okay.
Same logic even for cubic polynomials. Cubic polynomials we can sketch the graph also. Okay. I'm not expecting you to sketch this graph, of course. Okay. But
The
but
graph you get from there.
yeah,
Yeah.
the one on the right. Understand?
Yes.
So you can see that all these inequalities that I have here in this page, in these two pages, assumes that there are two x-intercepts, right? Which means that the discriminant must be positive. Get it?
Yeah.
So I'm still not answering that question that you actually worded yet. So these are still, all the coefficients are clear cut already. We are solving for x literally. We're not solving for any unknown constants at all.
Okay.
All right. Okay. So here we are still solving for x, right? So back to the, if we just extend the arguments that we had in terms of inferring the shapes of the graph to cubic, since this will help you actually. So a cubic polynomial, we will sidetrack for a while. So cubic polynomials, they are of the form ax cubed plus bx squared plus cx plus d is equals to 0, or no need equals to 0, just like this will do actually. So a cubic polynomial should have 3 roots in general because it's power 3 and 2 turning points, all right? So the shapes could be this way or this way, get it? So now if I have a situation where a is positive, so if I have 2x cubed plus bx plus 4x squared plus 5x minus 7, so which shape do you think it should be? The first one or the second one? But based on the arguments, the string of arguments that we had.
Should be the first one.
Okay, why?
Because the maximum point is first.
The maximum point is first. How does it work then?
That's what my teacher said.
Okay, so the argument should be like this. So as x goes to infinity, right? Okay, let's call this f then. Okay, this guy will be the most dominant term, right? So therefore, 2x cubed is positive and f is positive. Get it?
Yeah.
So, but as x goes to negative infinity, 2x cubed is still the most dominant term, right? But in this case, is 2x cubed positive or negative right now, actually?
It's actually negative because
it's negative. Yep. And hence f must be negative. So if you plot out the y-axis now, you will then see that it's the first graph that fits the narrative, right? The second graph actually gives you the opposite narrative. When x is infinity, y is infinity. When x is negative infinity, y is negative infinity. I mean negative.
All right.
Understand?
Yeah.
Or the one on the right is actually the opposite. So the one on the right must be when a is negative, then this is when a is positive actually. Understand?
Yes.
So same gameplay, even for solving for cubic polynomials, right? You must solve for the roots, and then based on the shape of the graph, which is based on the polarity of A, trace out the graph and analyze the shape accordingly. Get it? Like what I'm doing over here, actually. Understand?
Yes.
So with this, actually, we can actually talk about the stuff that you were talking about. So if you look at this, right?
Yeah.
Are we solving for x at all? If you look at my wording of all my 3 questions here.
No.
Okay, there's a typo here. This should be at k actually. Okay, so if you look at A first then. Okay, how will you do A? Or what is the question really asking?
Has no real roots. So we can move the 4 minus 5kx over to the other side. So then it would be x squared minus 4 minus 5kx plus k squared by plus 5. And then after that, if it has no real roots, then negative b squared over. So negative b squared. So
not negative b squared.
Isn't it negative b squared over 4ac is
b squared minus 4ac.
Oh yeah, sorry. B squared minus 4ac is greater than b squared minus 4ac is not greater than, sorry, it has no real roots, so it's less than 0.
Okay, so that's it. So you will then have minus, okay, minus doesn't really matter. So minus 4 minus 5k squared minus 4, 1, k squared plus 5 is less than 0 then. Get it now?
Yeah, and then you can draw the graph of this.
Yeah, and the graph is not the original graph. It's not this graph actually. It's just
it's just the other graph. Yeah. I get it now.
Understand now?
It was that simple.
Okay, so So we will actually, so that is where it gets really, really confusing for people when you have some other issues, okay? So, okay, let's finish this question for the sake of finishing this. So you
Okay.
have 16 minus 2040k plus 25k square minus 4k square minus 20 is less than 0. 21k square minus 40k minus 4 is less than 0. Okay? So assuming this is factorizable and everything, so you will have like, and you will just, this, then we will sketch the curve, right? This is a U-shaped curve, okay? This curve that we have here is actually this curve. Get it?
Mm-hmm.
So you would then have like, let's say if I have two roots, k2 and k1. So the final answer is, you want it to be negative, so it's between k1, k to k2 then. Get it?
Yes.
So all this curve that we are sketching here is not the original function, it's not this guy at all, okay? Understand?
Yes.
So this U-shaped curve that I have at the bottom is actually 21k squared. That's all. Get it?
Yeah.
So that's the whole point. And that's where it gets confusing for some people. They'll be like, hey, how come maybe the original question has got a negative leading coefficient, right? So they are anticipating an N-shaped curve. But when it popped up, it became a U-shaped curve, and they got really confused then. Okay, so you must understand what you are solving for. In this case, we are not solving for x at all. We are solving for k, the conditions, the coefficients that will give rise to the conditions that we seek.
Oh, all right.
Okay, so let's say if you do part C now, give it a shot.
K minus 2y intersects the curve at two distinct points. That means first we can equate k minus wait no. First we can equate k minus x over 2 is equal to, yeah, we can just make it y and then we can equate them. And then wait, if it's intersecting the curve at two distinct points, that's
Okay.
greater than.
Yeah.
So can't you just equate them and then you say that it's greater than or equal to 0?
Greater than 0, two distinct points.
Oh, just say yeah, it's greater than 0.
Okay. Get it now?
Yes.
So that's how these discussions are like. So we are not solving for x, we are solving for k actually. Get it?
Oh, yeah.
So even if okay, so there's no confusion here because if I sketch, even if I shift everything to the right side, I'll have 2x squared plus 2k plus 1x plus 16 minus k, right? This is originally a U-shaped graph. So even if I were to sketch this graph, which I shouldn't be, I'll be getting a U-shaped graph. But even so, I also need b squared minus 4ac to be positive. So I will also be sketching a U-shaped graph also then. Okay?
Yes.
So if you look at this one, this is the one that is tied into what you are asking me. Okay, this one. Maybe you there?
Yeah, I'm here. So do I just do D now?
Yes, yes.
X is less than negative 3 over 2. X is greater than 3 over 2.
No, but there's no x in, we're not solving for x, right, in this question?
Oh, sorry. A. A is less than 3 over 2 and A is greater than 3 over 2.
Okay, just read out your steps to me.
A is less than the negative 3 over 2. Okay, so ax squared plus 3x, ax squared minus 3x plus a is 0. But then it has to have no real roots. So then 9 minus 4a squared is less than 0. Negative 4a squared plus 9 is less than 0. That makes a is 3 over 2 or a is negative 3 over 2. So and then it's an n-shaped graph. So then yeah.
Okay, so we will actually so we will write like this.
Yeah.
Okay, so this is an n-shaped graph. Get it now?
Mm-hmm.
So this is 3 over 2 minus 3 over 2. Get it?
Mm-hmm.
Understand now? So your answer is on A, remember.
Yeah.
All right, can?
Oh wait, what? I thought it was less than 0.
Oh, yeah. Oops, my fault. Okay, we are interested in this arm and this arm. So it's this range of values and this range of values.
All right.
Okay?
Yeah.
All right. Okay. But ax squared minus 3x plus a, right? So what if the question is find a such that ax squared minus 3x plus a is positive for all values of x. This is what you're asking, right?
I think so. Wait, let me
If you contrast such a wording, right, to the original quadratic inequality questions that we have been solving, right? The original quadratic inequality questions have been like the let's say a graph that's like this, something like all these graphs, right? Okay, this graph here, 1a or 1b, right? It is occasionally positive, it is sometimes 0 at 2 points, and it is occasionally negative, right? Because I have got no other constants a affecting the shape of the graph, okay? And the question is asking you to tell me the occasions when it is positive, if you look at 1a. Get it? So we will go through the notion and solve for the occasions when the graph is positive, that's all.
Okay.
But if you look at the latest round of questions here, right, we are not saying that the graph is occasionally positive or negative or 0. I want it to be positive all the time. So the key phrase is this. Get it? So I want to control this such that the curve is positive all the time. So for it to be a positive curve, you must think in terms of two angles. What kind of shape must it be first?
Um.
Yeah.
It should be a U-shaped graph.
It has to be a U-shaped graph. And how many roots can it has?
It can have 2.
Would it have two roots?
Um. Would it not? Isn't it 2 roots?
If a graph has got two roots, right, that means it must cut the x-intercept, cut the x-axis, right?
Mm-hmm.
Such a graph, is it 100% positive then?
Oh wait, it's positive for all values.
Yes, that's the whole point. Understand?
Oh, so it's just a joke. It's just b squared minus 4ac is less than 0.
Less than 0. And it must be a U-shaped graph.
Huh? How do you do that?
Because this graph can't be an N-shaped graph. And N-shaped graph can't be 100% positive, right? At some point, you will breach the x-axis.
Uh-huh.
You get what I'm saying?
Yes.
So when you have such a question, the whole idea is this. Firstly, graph has to be U-shaped. The second thing is b squared minus 4ac has got to be less than 0. Understand?
Yeah.
Get what I'm saying over here?
Mm-hmm.
So with this two in place, what is the condition to satisfy number one? A has got to be greater than 0.
0.
That's the U-shaped graph. Then number two is, so minus 3 square minus 4a has got to be less than 0, right?
Yeah, so negative 4a squared plus 9, it has to be less than 0.
So this guy is less than 0. 3 minus 2a, 3 plus 2a. Okay. And
So you reject negative 3 over 2, and it's only a is greater than 3 over 2.
yep. Understand now?
Yes.
So 3 over 2, negative 3 over 2, right? So okay, by right, you will still say, oh, a is greater than 3 over 2, or a is less than minus 3 over 2. Get
And
it?
then you reject it.
Yeah, then we'll say take intersections of 1 and 2.
Oh.
So intersecting with this guy, this is an OR. So now it's 1 and 2. Means both guys must be satisfied simultaneously. So the net intersection must be this guy then.
Oh. Okay.
Okay. But the point is you must understand the idea, the wording of the question, how does it tag to the graphical situation interpretation actually.
All right. I understand.
Understand?
Yeah.
Okay. So of course we have many other situations, right? Let's say need ax square plus b square is 3 plus 9 16x plus a to be negative for all x again. Okay, how will you solve this?
That would just be a is less than 0, and b squared minus 4ac is less than 0.
B square minus 4 is less than 0, so be careful. So okay, so
So
a,
both are less than 0.
so it's always good to write this down. So n shape, okay?
Mm-hmm.
So
So
a
a needs
less
to be less than 0, and
than
then b squared
n.
minus 4ac has to be less than 0.
So no roots. So b square minus 4ac is less than 0. Get it now?
Yeah, I
So
do.
the whole idea is because to be able to realize this particular phrase, right? The shape of the graph and the position of the graph has got no other choice but to be something like this. No,
Yeah,
it can't be a U-shaped graph, and it has to be perpetually below the x-axis, right?
yeah.
So this means, yeah. So it must be. So the whole key observation is must be n-shaped and below x-axis for forever. Then understand?
Yeah.
If you master this, you have mastered quadratic equations already.
Yay. I understand it now.
Yeah.
It
Right.
took a while for me to understand at first, but now I understand
So
completely.
you must take it to the graphical interpretation all the time. Okay, it makes it easier actually.
All
Okay.
right.
So when you pack it to your graphical interpretation, it makes studying of logarithm and exponential graphs easier also, is to treat
Ah,
that section. Because trigo graphs are coming your way in 2 weeks' time also. Okay.
yeah.
All right, understand?
Mm-hmm.
So any other questions on quadratic then? Otherwise, we can end off here today actually.
Oh.
I mean, you have
Oh,
no issues with completing the squares and everything, right?
yeah, no.
I need to look for Pavan anyway. Yeah. All right.
Okay. Goodbye.
I'll send it to the Google Drive. All right.
Thank you so much.
Cheers. Bye bye.
Goodbye.